So up until now, we've only looked at compounding interest where the interest is compounded annually. Now, interest can be compounded more than once a year. It can be compounded half yearly or quarterly or even monthly. So here they give an example of where there's an investment and the interest is compounded quarterly, and they go through how you could work out what the interest earned would be for each one of those quarters over the 3-year period, and then they generalize a formula. So you can see that this generalized formula is very similar to what we have been using so far for compound interest, but now we have the addition of the I over k and the k times n in the exponent. So in our previous examples, where the interest was just compounded yearly, you'll notice if k was 1, so if this k was 1, that means that the compounding interest only happened once a year, then that would give us that original formula we're using. So the only addition now is this k, and the k relates to how many times the interest is compounded per year. So we'll do an example to have a look at this. So in your exercise books, could you just write a title, different compounding periods, and copy this formula in, and then you can work through this example with me. So $8,800 is placed in an account which pays 4.8% per annum, and the interest is compounded monthly. So if it's compounded monthly, that means over the year it would be compounded 12 times, and they want to know what the balance is after 3 years. So we'll use this formula here to determine this. So as always, it's a good idea to start by writing that compounding formula. So FV, or the future value, is equal to the present value, or the principal, times 1 plus the interest rate over the number of times that it's compounded per year, which is k, to the power of n, k times n, where n is the number of years. Now, for this example here, we have our principal value of 8,800. So PV is equal to 8,800. The interest rate in this example is 4.8% per annum. So 4.8%, which is equal to 0.048. Then, like I said, since it's compounded monthly, over the year, the interest is compounded 12 times. So k is equal to 12. And finally, the number of years that the number of years is 3 years, so n is equal to 3. So now it's just a matter of substituting these values into our formula. So FV is equal to our present value, or our principal, 8,800 times 1 plus, now our interest rate is 0.048 divided by our number of compounding periods, which is 12, times k is 12 times n is 3, and now it's just a value of now we just have to put this into our calculator. So 0.048 divided by 12 plus 1 to the power of, so I've just done what's in that bracket. 12 times 3 is 36. And then I have to times it by my principal, 8,800, which gives me 10,160 and 6 cents. So 10,160.06. Remember to ensure that you're rounding to the correct number of decimal places. So we'll go 2 decimal places. You have to check the third. Since that's less than a 5, that stays as a 6. So the questions I'd like you to work through now are from chapter 3C.3. So they're listed here. and just make sure that you're applying the formula that we've just been introduced to, which takes into account how many times the interest is compounded per year. So again, if it says monthly, that means that it compounds 12 times in a year. If it says quarterly, that means that the interest is compounded 4 times per year.